Okay, welcome everyone. We're really excited to have you all here for our second developer school and our second kickoff event for the Autumn Developer School. So today we're going to be kicking everything off. To give you a brief overview of this event, first, Matthew, who is here on my left, he'll be giving us a presentation on the Linera protocol, followed by myself giving a short presentation on the program specifics, resources, and also how to be successful within the program. So with that being said, Matthew, I'll let you go ahead and share your screen and give us your presentation.
Yeah, thanks, Jesse. Okay, so let's see. Share my screen here. Okay, here and here. Yep. All right. All good, Jesse. So, yeah. Okay. Cool. So, yeah. Thanks for the introduction. It's a great pleasure to be here and to be able to present the Linera protocol and to kick off the developer school, the Autumn Developer School of Linera. So Linera is a project that is based on research I did at Facebook a few years ago, and that evolved a lot since then. Our goal is to create a new kind of layer one infrastructure, a new kind of blockchain infrastructure that gives users their own block space. And so, what does it mean, and why would we want to do that? And so I'll start with like a very simple analogy. So so if you have a car and let's say the car represents some assets you have on chain, okay? There could be a scenario where you have your car in the middle of a very secure but very crowded parking lot, and there could be a scenario where you have your car in your own garage, and so if you have your car in the parking lot and you want to move your car, the first thing you need to do is to find the valet, and then maybe there's going to be other users that need to move their car first, and it can take a little bit of time, okay? As opposed to if you have your own garage, you can just take the keys of your car and take your car and just use it to go wherever you want. So when you have your own block space, what we're saying is essentially that you can take your assets and move them out of your chain whenever you want, and that's what we're building for. And in fact, in general, Linera is an infrastructure where we want to really prioritize high quality interactions for Web3 applications, and especially high quality when the number of active users is unlimited, so at internet scale. And the prime with architecture that are based on a few chains of blocks, as is the case for many architecture right now. The problem is that so it makes the users compete for block space. They need to compete with each other to put their transactions inside the block. And it means since the situation of the parking lot where sometimes some users are going to be in front of you, maybe they pay more fees and so they win the auction and you have to wait. And although you own the assets, you are not able to just move them or interact with the system with constant latency or constant fees. And so constant fees in particular, and so it means that Web3 in this case, the Web3 applications, you can feel that they are not quite as good as the Web2 applications, and that's really what we want to solve. So how are we going to do this? So we want users not to compete for block space. So we want somehow to reserve some block space for each user. And so block space is a space in a chain of blocks. So what can we do to give users their own block space? Well, we're going to give them their own chain of blocks. And in general, Linera is a system where we organize block space into an unlimited number of parallel chains of blocks that can be extended independently. And in fact, we have a name for them. We call them microchains. So now if we get into the technical details, so we are going to have a system where we have a potentially unlimited number of parallel chains of blocks, parallel microchains, but we want them to be able to interact very efficiently. We want also them to have the same level of very high level of security, and so we're going to put them in a single set of validators. That's going to be very helpful for question messaging, for reasoning about the security of the protocol, and then each validator now has all those chains that are parallel and mostly independent, and each validator can apply just usual techniques from the Web 2 called internal sharding. So the structure of a validator is going to look like a normal web system with a front end, a number of workers, and maybe a shared database. And the idea is that if you have lots of chains that are really active, really hot, you will typically put them on separate workers, and then maybe at some point you have to add workers. And in this way, you can add capacity to each validator and providing a constant quality of service to every user in the Linera system. Okay, and so I was mentioning some previous research that inspired this line of work with some colleagues from Facebook. And initially, it was a decentralized payment system, and so we didn't have blocks. We only have user accounts, and we knew how to make some transfers between the user accounts in a scalable way. But we didn't know how to have smart contracts among other things. And so, really massive generalization of a payment system called FastPay, and to which we had the notion of chains, we had the notion of smart contract, and in the end, it becomes this really interesting new architecture, like a full layer one that can be programmed and to achieve this high quality Web3 applications. And so also another word on the diagram on the left side. So we see that we have a number of chains, parallel chains between each other. They're going to communicate using question messages. And now the question also is, how do we extend a chain? And so all the chains, they are validated in the same way. They have the same level of security, but there's going to be a difference in which the chains are extended. And so for a particular chain, so validation, like I said, is the same for every chain, but block production can be very different. So some of the chains, if they belong to a user, it means that the user has a permanent has the possibility to propose a block to extend their chain at any time, and they are just a sort of permanent leader or permanent block proposer in their chain. So there are different types of chains in the Linera system. In this talk, I will just talk about the simplest case, which is the user chains, the chains that belong to a single user, or just to a group of users that collaborate with each other. Okay, and so once again, so we have, that's nice. We have all those chains, and how does it help scaling Web3 applications? And the answer is so it depends maybe on the applications, but what we're optimizing for is really what we think a new kind of applications for that is not addressed in current systems. And so what we want is really to be able to, with this notion of microchains, we want really to help high quality applications in the case where in the case that is relatively general, where the state of the application is organized in user accounts and objects that are loosely interacting. And that's really the case for many applications that are micropayments, or social applications. But there are other systems. If you want to do e-commerce, you have users and you have auctions, and we will give each user account and each auction object their own chain. That's the philosophy of Linera. And so we're not optimizing for applications that require a shared state between all of the users. So that would be typically AMMs, order books. If you want to do flash loans, then it's definitely better to do that in a single chain of block. But we are really interested in extending the frontiers of Web3 applications at scale. And so we are really interested in Linera with the kind of applications for which you have user accounts and objects that are interacting. As is the case in a lot of Web2 systems. Okay, so that was the introduction. Now I'm going to give a brief overview of the protocol, and then I will talk about the Linera SDK and conclude. Okay, so and I'm talking about the protocol again more in the case of user chains. So remember, so we have one set of validators, and they are each of them is tasked with the role. Each validator is validating all the chains. So they have a small replica, a small full node for each of the parallel chains. And so in the case of a user chain, in this diagram, the user chain B, so you'd have a copy of the chain that is inside the user wallet, and the user may decide that they want to move their assets out of the chain, so they want to add a block. And so the nice thing about this setup is that, and the nice thing about user chain is that in the simplest case, you have a very simplified protocol to extend your user chain that doesn't require a full consensus protocol. And so the protocol essentially is the following: the user will put together a few transactions in a block, describing what they want to do with their account, and then they broadcast the block to all the validators in parallel. And so if the block is valid, the validators are going to sign a statement that says, okay, this block is valid, is a good extension of the chain D, and then the user wallet can aggregate all those, can recover all the signatures, and once you reach a quorum, so that's like 2/3 of the voting rights in the validator, you obtain a certificate, and you just need to, so the transaction is already, the block is already final, and now the only thing you need to do is to broadcast this block to the validators again so that they can execute it. So one interesting thing also to notice in this setup is that in Linera, user wallets, they are the center, they are really at the center of the protocol, and the validators, in contrast, don't talk to each other in the normal case. At least in the case of user chains, the validators don't really gossip anything. They are essentially passive services, which helps a lot with the scaling and with the operational costs. Okay, so I was talking about the notion of quorum. So Linera is a proof of stake system that is using a notion of quorum. So it's relying on classical notion of security that comes from the word of BFT consensus, Byzantine fault tolerant consensus protocols. So it's extremely classic. It's the security assumptions are exactly the same as a single sovereign chain that would run a proof of stake system just out of a textbook. And that's a very nice thing to have, because on the other hand, our execution system is having all those parallel chains. But turns out, from a security point of view, the system is actually very classic and very easy to analyze. There's no particular the fact that adding new chains, for instance, doesn't change anything to the security. All the chains are already running the same software in the same validators. Okay, and so now, how does it work when you want to program an application that does something useful? And something useful is generally require users to interact with each other or to interact with some objects. And that's more often than not, that requires sending messages from one chain to the other. Okay, and so the way it works in Linera is that when a block is executed, the block can modify the state of the chain, of course, as usual, but it will also be able to schedule an asynchronous message to be sent to another chain. And so that message, what's going to happen is that it's going to travel in every validator in parallel and be stored in the inbox of the receiver chain and wait there for the next block of the receiver chain to pick the message. So there are two types of transactions in the block: operations that are the initial things you want to do, the initial commands that you want to do on the state of the chain, and incoming messages, which is when you have received something that is waiting to be picked in the inbox, you want to say to the system, okay, I actually want to execute that message that is incoming and execute it for real. And so, interestingly, we leave the inboxes, the messages in the inboxes are not executed immediately. They are really waiting, and the result is that they can arrive at different times depending on the validator. And so, to maintain the consistency of the system, we them in their inbox, and only when the receiver decides to execute the messages, the next block of the receiver will tell us in which order to execute the incoming messages. So that's one of the specificity of the system that is worth noting. Okay, So that was an overview of the protocol in the C+ case. Of course, in the general case, there are like the clients have a little more work to do than just the 3 messages I was describing in the previous slide, and they have to update. For instance, they may have to provide missing blocks to validators that might be lagging. And so when you want to, and so if you want to receive funds from a chain A as the wallet of B, you may want to you may need to help the validator learn the missing blocks of A until the block that actually sends you money. And that's something that is also very special in our system, where we really put the wallets at the center, and the validators tend to be very lazy and don't want to work in advance until a user actually tells them, I really need these blocks to be executed. Okay, these are the blocks. Of course, the validators, when you execute blocks, there's always a validator. So once a block is executed, the validators are storing the block and are very glad to give you back the block when you ask. So the blocks are not lost. We don't rely on users to store the blocks, but we may rely on users to transfer the blocks to some validators that maybe were disconnected and are reconnecting. And so I mentioned also that in this talk, we're at least in this presentation, I was describing user chains, but there are more complex scenarios where you have a full BFT protocol to control how a chain is extended. And that's if you want to have multiple owners using the same chain, as basically is the if you wanted to use an order book chain or a name chain, that's typically the kind of more complex protocol you would use. Another thing also that is interesting is that the wallets, since they have this direct relationship with each of the validators, they can also ask. In practice, they actually want to be notified when they receive messages. So you can leave a channel open with the validator and obtain notifications when somebody sends you money, which is kind of cool. It allows having UIs that are reactive, and having a system where if somebody sends you money, the UI can immediately be accept the money and show you your bank account. I mean, show your account has been updated, right? Okay. So that was an overview of the protocol. And so the good news is that you don't need to think about the internal protocol, how validators communicate with the wallets. What you need to understand is more like how the application is structured and what is the state of the application, what are the kind of messages that are used to communicate with other chains, how you compose the application with each other, and that's the role of the SDK. So remember, there are 2 kinds of transactions: the operations and the incoming messages. And so now, when it comes to smart contracts to programming new applications, the cross messages specifically that we made, when they are sent by an application, they go to another chain, and on the receiving side, they're executed by the same application. So you have the same code on the sending side and the receiving side. Okay, and that's quite a lot of the reasoning, and that means that the exact format of messages is something that is internal to an application. There are 2 kinds of applications. There's the system application that is programmed in Rust and is sort of part of the protocol, and there are user applications that are written in Rust and executed in the WebAssembly VM. And so, of course, in the future, we may want to, we could also support other languages, but at the moment, it's applications that are written in Rust. When you want applications, so you have your code, you compile it into WASM bytecode, and so you can one of your chain, and then you bytecode into. So essentially, bytecode means just providing you some of the parameters of the application. So if your bytecode is describing the equivalent of ERC20, how to create new tokens, you would typically instantiate it into a new token by providing the name of the token, and the number of parameters, like the amount of tokens, initial amount of tokens, and that kind of parameters. Okay, so we use applications. Linera applications can share bytecode, so you don't have to upload a new bytecode, a new program every time to have a new application. You can just maybe instantiate an existing bytecode to do that. And so another thing also is like when I said that the messages, the question messages, they are sent by an application and they're received by the same application on the other side. And that means that perhaps sometimes the receiving chain, when the message is when it's the first time that a message is sent to this chain for a particular application, the system may actually under the hood may auto deploy the application. So maybe the chain X in this diagram has never used this particular application, but that's okay. We will just every validator will just request the bytecode or find it if they have it already, and then make that and then run it to process the message, the incoming message. Also, another thing is that inside the question messages are, as I said, the sending and the sender and the receiver side are running the same code, the same application. But now, when you want to compose application, you can do that inside a chain and arbitrarily, in the same way as Ethereum is composing smart contracts. You can compose different applications. They can call each other using function calls, as usual in most blockchain systems. And the calls are not asynchronous. The calls are blocking. All right. So to illustrate the Linera SDK, so I wanted to take this very the example of a payment application. And so in a payment application, you would have, or actually the definition of tokens, you would have a state that is the balance of the user. So it would be a map from addresses to a certain amount of tokens owned by each address. And that state would be typically how you see the state of an application in any chain. Any chain has a map of balances to from addresses to balances. And now, if you want to transfer tokens from one user to one user in one chain to another user in another chain, and so you would need to be the owner of the sending chain to be able to create a block, and you would execute an operation transfer that says, okay, I want to take out some amount from this chain and this address and send it to another chain and another address. And actually, there are a few parameters that are missing in this example. So and that operation is going to send a message, okay, credit that says to the chain X, okay, when you execute the operation, it's going to burn the assets in the receiver chain, in the sender chain B, and sends a message to the receiver chain X in this case. And so sending the message, so you burn the asset on the sender side, you send a message, and then on the receiver side, when you receive credit, it means you mint the asset on the other side. So what's interesting is that we have a payment system described here with a few messages, with one message, one command, and just a map of balances, and that's already a horizontally scalable payment system out of the box using the framework of Linera. Okay, now what happens if you make a mistake? You send some money to a chain, but in fact you didn't mean to do that. If the account on the receiver side is still the same address as you had, so you morally speaking, it's still your coin, so you could send a message to claim, and so you'll be able to say, okay, I have under my address, I have some under an address I control. I have some coins in a different chain, so now I want to claim them, so to bring them back to my favorite user chain, and so you can send a message claim, and that's possible because messages can carry the authentication of the block that created them optionally. That's for the example of the payment application. There are of course other features that in the SDK that allow people to create much more interesting applications than just payments. We support pub/sub channels, and in one of the apps, like social app. And I mentioned also that user chains is one of the type of chains, and we're developing new kinds of chains for temporary interactions and also for public to obtain a chain that is self-extending, so the chains managed by validators. We're also working on redundancy in sessions. Those things are not available just yet in the SDK, but they are well on the way. Something also very interesting in the framework is that from version 1, we have in every application, there are actually 2 bytecode, 2 binaries, one for the smart contract part that is essentially the one I was describing, and another one that is a GraphQL service that is meant for UIs to easily access the state of an application on a living chain. And that's something that is very convenient, and we think to simplify the development of applications by avoiding API providers in many cases. And I should also mention everything, the SDK is type safe, it's programming Rust, and we use APIs to make sure that when you serialize a question messages and want to send it to another chain, you use the expected serialization format and the expected types out of the box by default in the SDK. And so, yeah, and for more details, our development manual is available at Linera.dev. So that was my presentation of the Linera SDK. So to summarize, scaling Web3 application has been obviously a problem that has been studied and for a very long time, and there are many solutions that are being proposed. Layer 2s, in fact, getting the abstractions lately. Linera, we're interested in different trade-offs. Don't prioritize applications that want a shared state in all the users. So with the are very good for putting the states of a single application on a single for the state of all the users on a single chain. But there are some, if you want to scale this up, validation, and then when you have many layer 2s, there's the question of how you communicate between the layer 2s, which is not easy. So in Linera, we are studying a different kind of applications that we think will really benefit from independent that are more naturally organized in terms of user accounts and objects, and that's what we're going to we think is going to really benefit from the microchain for the system of the many parallel chains of blocks in Linera. In general, we high quality user experience, and from day one we have so GraphQL services that help web UIs interact with the user chain, and we think that that's really the direction that is required to provide a high quality user experience, really putting the wallets at the center, back at the center. And that's what we're working on by giving users their own wallets. All right, so that was my presentation.
Thanks, Matthew. Thanks for that overview. I will share my slides in just a moment here, and I'll go into the program specifics. Okay, so like I said, my presentation is going to be in regards to the specifics of the developer school, how to be successful, and some resources that you'll be able to find within the Linera community. So first off, I'd just like to outline in a broader sense what this program has to offer and what the opportunities are. So by participating in this program, you'll gain practical experience with the Linera SDK and Web3 programming, You'll be among the first to learn Linera's multi-chain architecture. You'll participate in live events and workshops with the Linera community and team, and build a locally run Web3 application using the Linera SDK. And of course, you'll have a chance to win from our $12.5 thousand prize pool, as well as some digital credentials that we're setting up now as well. Here's the calendar of events for the program. Make sure to check this out on DoraHacks under the schedule tab. I would also make sure to check in on this periodically, just in case we decide to add any more programming based on the feedback we receive during the course of the program. So far, this includes 4 coding workshops to help you get set up with the SDK. And make sure also to look out on Twitter, Discord, and Telegram for any other updates as well. For your submission, we're going to keep things broad to allow creative freedom. So you must build a Web3 application that runs locally using Linera SDK. And the most important things to submit are a URL to a public code repository where the code is open source, as well as a 3 to 5 minute video explaining what you've submitted. The main resource that you'll be using for your submission is the developer documentation at linera.dev. This includes a comprehensive guide to the Linera SDK, and it'll get you started with installing Linera, running a local development network, and writing your first application. It's also going to give you some background on advanced concepts like how the Linera blockchain works. And if you want to dive even deeper, you're welcome to read the Linera white paper on our website as well. So what can you actually build with the Linera SDK? Linera is optimized for Web3 applications that require processing high volumes of time-sensitive transactions created by many users in parallel. At the time of this presentation, we don't yet have a testnet, mainnet, or token. And given the current state of the project, we recommend building a simple application that incorporates some of the following features: real-time micropayments or micro rewards, messaging functionality, or a Web3 social app with a newsfeed. We've also created a few demo applications that you can view on our GitHub. The link is also shared in the developer resources section on DoraHacks, so make sure to check that out as well. We have a few more than 3 example applications, but I've decided just to show these 3 for now, because I think these 3 demonstrate the range of the apps that you can build. So here you can see Fungible, fungible token, an app that demonstrates cross-chain messages, a social app where users can subscribe to other users and they can make text-based posts, as well as a crowdfunding app that uses the token from the Fungible application. And if you need even more inspiration, you can check out some of the projects submitted during our developer summer school that was hosted on DevPost. We had a range of high quality submissions across multiple different domains. The top 3 winners were ResPeer, a peer-to-peer content publishing application, Equalizer, a revenue-based financing protocol, and Linera Logger, which was a tool that explores the Linera network with transaction lists, block inspections, and metrics. So I'd highly recommend checking this out. I welcome all of you to check out the Linera Developer Summer School on DevPost. I would also highly recommend checking out the previous coding workshops held during the Developer Summer School on our YouTube channel. They're still a very useful resource, and our future coding workshops for this session will be based off of these with added updates and improvements. We'll also have an additional 4th coding workshop to introduce some new content that wasn't covered in the Developer Summer School. So in terms of prize pool breakdown, there's going to be 8 prizes in total, which includes a prize for 1st place through 5th place, as well as 3 honorable mention prizes. Each prize will also come with a digital certificate. There are no category-specific prizes or tracks. All prizes are for the best application built on the Linera SDK, so we invite you to be creative. And the total prize pool will add up to 12.5K USD, and the winners will be up to the discretion of the judges. The criteria that will be used to judge your application will be technological implementation, design, potential impact, and idea quality. And all 4 of these categories will be given a rating out of 5. So here are the judges. All judges are members of the Linera team, including both myself and Matthew. Here's our Twitter, Telegram, and Discord if you'd like to join our community and stay up to date with the Linera ecosystem. I'd highly recommend joining the Linera Developer School channel and support tickets channel in our Discord for any technical questions you may have. And that's it for now. So thank you everyone for being here. We're really looking forward to seeing what you build, and we're hoping to have another really successful developer school program. So thanks, everybody. It was great to see you, and we'll talk to you at the coding workshop tomorrow. Bye.
Thanks, Jesse. Thanks, everybody.